All right, so we're going to be proving the converse of the perpendicular bisector theorem here in this video, and we are given a bunch of information. So first off, we're given that PA is congruent to PB, and we're given that PM is perpendicular to AB at M. So that's helpful. All of that is my given information. I'm just going to put it underneath the same reason. So I know that this line is congruent to this line, and I know that this is going to be perpendicular. So if I know that they're perpendicular, then I know that angle AMP and angle BMP are right angles. And that is just using the definition of perpendicular. Fantastic. And they're perpendicular to M. That is literally the only information I know other than this side is already there. Well, this gives me an interesting thing that we can do, especially because I know I'm going to be using Pythagorean theorem. If I'm going to be doing Pythagorean theorem, I need right triangles. So I've just said that these are right angles. So now I can say that triangle AMP and triangle BMP are right triangles. And this is just by the definition of right triangles. Right triangles are defined as triangles that have exactly one right angle. These are triangles with exactly one right angle. Right triangles. We can get there. All right. So with that, we can now set up the Pythagorean theorem. So let's go ahead and set up that Pythagorean theorem. Now remember that A and B are the sides that are around the right angle. So this would be A, this would be B, and then C is always the side that's across from the right angle. Now A and B can switch places. It honestly doesn't matter. But because we have right triangles, now we can use Pythagorean theorem. So I can say that AM squared plus MP squared is going to equal AP squared. I also have that BM squared plus MP squared equals PB squared. And this is just Pythagorean theorem. Okay. So now I do know something, and I'm going to go to the next one. I do know that PA is congruent to PB. So I'm going to be replacing PA with PB. So I know that AM squared plus MP squared equals PB squared, because remember we could replace PA with PB, and then the other side is going to, so the other side didn't change, right? And we just did substitution here. We just replaced PA with PB. So with that, now I have two things equal to PB squared. So now I can do the transitive property, and I can say that AM squared plus MP squared equals BM squared plus MP squared. Now notice that MP squared is on both sides, so I'm going to use the subtraction property of equality to get rid of it. So if we subtract MP squared from both sides, I get AM squared equals BM squared. And then from here, we can take the square root of both sides, and we would get AM equals BM. Square root property of equality. Sure. As long as we do it to both sides, we're allowed. It's the rule. So now that they're equal, I can say that AM is congruent to BM by the definition of congruence. So from that, now we already know that they're perpendicular lines, and we know that AB was cut in half. So we know that M is the midpoint. So because of that, we are able to say that PM is the perpendicular bisector of AB. Because we went through the process of showing that those are cut in half, and it already gave me that it's perpendicular. So this is using the definition of a perpendicular bisector. All right, well, you guys now get to do this tiny little proof. You're just proving that this triangle here is congruent to this triangle here. Then you guys are going to prove over here that angle P and angle R are congruent. You probably want to prove that the triangles are congruent, and then use CP, CTC to find some more. Then we will meet back here talking about the point of congruency.